Today's lesson is going to be about directional bearings. Unlike all the other triangles that we've studied throughout the semester, directional bearings, when you draw them and you use them, you're going to draw all your triangles off of a north-south line because we're going to be using cardinal directions, north, south, east, west. So that's what it's saying here. Bearings, acute angle formed with a fixed north-south line. So an example would be north 60 degrees east. So what that does is you start here at the origin and you're going to go to the north axis on your y-axis. You're going to rotate 60 degrees to the east. So this would be north, east, south, west. Now, there's little sayings you can remember those. Never eat soggy waffles, never eat shredded wheat, all kinds of different ways to remember north, south, east, west. But that's how you read that. North tells you to go to the positive y-axis, rotate to the east 60 degrees, and then what you do is you draw your triangle to the north axis, and then you have a right triangle that you can work with. Okay? So what we're going to do is we're going to look at some examples. Okay, it says a ship leaves port at noon and heads due west at 20 knots. 20 knots is a speed, it's like miles per hour, so knots is nautical miles per hour. At 2 p.m., the course changes course to north 54 degrees west. Find the ship's bearings and distance from the port at 3 p.m. Okay, so the ship leaves port at noon and heads west. So we head west this direction for 2 hours because it says at 2 it changes course at 20 knots. Okay, well then what happens is that north-south line is now going to be fixed here to figure out the next part because we are now here after 2 hours. So it takes 2 hours to get here. Okay, and then from here it goes north 54 degrees to the west. So what happens is now the ship starts to travel this direction. Okay, and we know that because this is 54 degrees from here to here. Now, it says at 3 p.m., how far is it from the port? The port's right here, okay? So the ship is now right here. So what I want to know is I want to know the distance there. I want to know D, okay? So what we got to do is we got to figure out some information, okay? So we start piecing this together. So we know that this right here is 54 degrees. Okay, we can figure out this right here. Okay, because this is a north line, this is an east and west line. So this is 54. This would be, what is that? It's going to be 36. So it has to be 90. This over here would be a 90-degree angle. So we know that the big angle here, okay, would be 90 plus 54, which would be 144. Okay. What we got to do now is we got to figure out some distances. So we use distance equals rate times time. Distance equals rate times time. So what happens is this blue line right here going straight west, we traveled for 2 hours at 20 knots. So this distance right here would be 40 knots. Okay. It says at 2 p.m. the ship changes course and heads this direction in the same direction. So what happens is we head in this direction for 1 hour. So this length here would be 20 knots. And the reason how I got that is because it says leaves at noon, travel, and at 2 p.m. we change direction. So we travel this direction for 2 hours, travel this direction for 1 hour. Obviously, this triangle is not drawn to scale. So what happens now is you have this triangle. We have some information. So sometimes the easiest way is to transpose this over here. So what I'm going to do is I'm going to draw this triangle over here. So we know that this is 20, or excuse me, that's 40. Okay, this is 40. This one here is 20. This angle right here is 144. So then what happens is this is a non-right triangle. We're trying to figure out this side length over here. Well, we're going to have to use law of sines or law of cosines. In this case, we're going to have to use law of cosines. So what it would look like would be x squared equals 20 squared plus 40 squared minus 2 times 20 times 40 cosine 144. Okay, Once you have that, type that into the calculator, hit enter, and you would then take the square root. So when I type this into the calculator, I end up getting x squared equals 3,294.43. Take the square root of that and you get x equals 57.4 nautical miles. Okay, so that's how you set that up. So you have to be able to read, understand how to draw the diagram, and then go from there. So let's look at the next one. Okay, so the sailboat leaves a pier and heads due west at 8 knots. After 15 minutes, the sailboat changes course to north 16 degrees west at 10 knots. Find the sailboat's bearings at a distance from the pier after 12 minutes on this course. So what has to happen is, this one's a little different because it says minutes. Minutes, 15 minutes is 1/4 of an hour. And knots is nautical miles per hour. So we have to get our time frames in the same thing. So 15 minutes is 1/4 of an hour. 12 minutes, okay, so what we have to do is we have to convert minutes to hours. So we need to use a line conversion. 12, I want to put minutes in the denominator. So there's 60 minutes for every 1 hour. Multiply straight across, you get 12 over 60, which reduces to 1/5 of an hour. Okay, so what happens is we travel for 1/4 of an hour straight west. Okay, so we get to here in 15 minutes, and then we head 16 degrees north. So we head this direction, which is 16 degrees from west from the north line. So what we want to do is, it says find the sailboat's bearing and distance from the pier after 12 minutes. So what we have to do is we have to figure out this distance here, and then it says find the sailboat's bearings. The bearings are going to be this angle right here. So we need to figure out the distance from here to here. So we traveled at 8 knots for 1/4 of an hour. So distance equals rate times time. So distance equals rate times time. Our rate was 8 knots. We traveled at 1/4 of an hour. So 8 times 1/4 would be 2. So the distance from here to here is 2. Okay, so then what we do is we do the same thing when we travel from here to here, but notice when we change, we are now going at 10 knots. So it'd be 10 times 1/5. 10 times 1/5 is 2. So then we have 2 right here and 2 right here. We know that this angle, big angle right here, is going to be 90 plus 16, which would be 106 degrees. So what I like to do is I like to clean this up a little bit, draw a new triangle. So I have a triangle that looks something like this. Okay, this distance here is 2. This distance here is 2. This angle right here is 106 degrees. So then what we're trying to do is we're trying to find out what this is right here. Okay, so we're going to set up a law of cosines. So it'd be x squared equals 2 squared plus 2 squared minus 2 times 2 times 2. Cosine of 106. Use the calculator to find out what x is. And when you use a calculator and take the square root, you get x equals 3.19. So that's the distance. This right here is 3.19. Now what we need to do is we need to figure out this angle right here, because we need to find the directional bearings. So what I got to do is I got to find out this angle, which is right here in the triangle. And then if I know this angle, then this one up here and this one here would add up to be 90, and we can do our directional bearings from there. So what I got to do now is I got to set up and find out this. So what I'm going to do is now I'm going to use law of sines. So it's going to be sine of 106 divided by 3.19 equals, I'm solving for this angle, so I'm going to use this side over here. So it's going to be sine of a variable, call it A, whatever you want, for the angle here, A, or P for port, or wherever. Okay, 2, cross multiply and solve. So you're going to get 2 sine 106 equals 3.19 sine A. Divide by 3.19. on both sides. Take the inverse to figure out what A is. And use your calculator and we'll figure out what that is. So angle A is 37.06 degrees. Okay. So then that's the angle right here is 37.06 degrees. So this angle up here would be 90 minus that. So 90 minus that answer would be 52.949394, depending on how you round. So there's that. So the bearings, okay, so your bearings.
Well, hello, Grand Valley High School. Mr. Brooks with a couple of announcements. First,
Okay, so 52.94 is the angle here. So we have to do our bearing based off the north line. So from the north line, we rotate 52.94 degrees to the west. So then our bearing would read north from the north line, 52.94 degrees to the west.